morning, everyone. It's my pleasure and honor to be here part of this webinar, and I will try to give you an overview about the status of the transformation of the steel industry in the EU. Since my speaking time is very restricted, I, I will work through my program just quickly, because I prepared much more information for you than I can present here, but don't worry, all the presentations will be available as a PDF for you to read it after. So please excuse me when I quickly jump over the contents. I prepared 8 agenda points. After an introduction, I will briefly report about the legislation situation in Europe. We will talk about financing of the capex for the transformation, production cost development for green steel is another point on the agenda. Then, of course, we have to discuss the challenges which are coming up, which is basically raw materials being used in the future for the green steel production. Then we will look a little bit into the technologies which are on the market and available. We will talk about operational challenges with these new technologies, and at the end, I will give a summary and an outlook. So Karim introduced myself, so I don't have to do it again. Let's start with the basics, which is the global warming discussion. I mean, most of you might know this picture already. We are facing.
Jürgen, can you switch on your camera? It will be better if you are a speaker.
No, it's okay, but the problem is I cannot switch on my camera. Can you see me?
No, we don't see you.
Yeah, but you have stopped, Karim.
Try again. I mean, if it's working, if not, then okay, disregard my question.
No, I'm sorry. I'm now in the presentation mode. So first, okay, let's go ahead like this. Huh? Okay, now I can. Okay, good. Okay now?
Thank you. Yes, please go ahead.
Okay, so most of you know about this situation. I mean, if we do nothing, then we will face a temperature increase global of about almost 5 degrees. With the current policies implemented, we will face a temperature increase by 3 degrees, but our aim is to reduce it to 1.5, and we have introduced pathways to reach it. If we will reach it, we will see after, let's say, the timeline has passed. So why is the steel industry in the focus? The steel industry is in the focus because it contributes with roughly 7% to the total CO2 emissions. That seems to be very small, but at the end of the day, the chance here is that a huge amount of emissions can be cut by focusing on not a general and let's say a measure, but to focus on singular hotspots, which can be transformed for lower carbon emission. Why steel industry is in the focus? Because the steel industry has the biggest share amongst all the other heavy industries, and that's why they started here. Okay, let's look into the legislation. The whole topic started with these climate change conferences of the parties, or COPs, in 1992, where first time the reduction, the link was between the global warming and the CO2 content in the atmosphere. It lasts until December 1997 to sign then the first agreement called the Kyoto Protocol to reduce the global emissions. And in 2015, at the end in Paris, so it means after 23 years, we had at the end the first agreement to reduce globally the warming down to a rate of 1.5 centigrades in total. You can see here the history of the conferences. Almost every year a conference is held somewhere, but to come to a general agreement is very difficult. Some of the highest emitters of CO2 emissions are not even participating, and the others always are fighting to get a general agreement about the next steps. This year in Baku, it was about financing and compensating the damages of the global warming. I mean, for sure you heard that there was a big request on money transfer from the north, industrialized north, to the global south. And at the end of the day, they came to a number, but USA was not participating for what reason ever. So I wonder if this is really a valuable agreement or just a promise. Anyway, in Europe, already in 2005, the activities started to reduce the emissions in general, and it became a EU law in the meantime. And you can see here the path of the reduction. As you see the historical reduction shown in the dark curve, and then you see the predictions. And basically, the conclusion is that the EU has committed to reduce their emissions by 55% by 55% until 2030, and to become carbon neutral in 2045. Yeah, and this EU law was then transferred to the countries. And here in the map, you can see that not all countries so far have contributed, but a lot of countries have converted these EU laws in national laws. And in Germany, the target is now to become carbon neutral even earlier, and already in 2045. And the reduction in the first phase should, let's say, already be at minus 65% in 2030. Some point has to be mentioned. Carbon neutrality or zero carbon is not requested from the EU, but it's requested from the countries. Yeah, so this is a big difference. And of course, this is causing some discussion, but we will come back to that later on. Let's look to financing, because all transformations requires the implementation of new technologies. New technologies requires CapEx, and the CapEx must be financed from somewhere. Yeah, and the CapEx amount for the first transformation was already be estimated by business consultants and other people. And the first round, which will only be, let's say, maximum, I would say 40% of the transformation, will already cost 30 billion euros direct investment. So the question was how to stem this money. And this can only be possible by providing funds. In the European Union, there are several pillars that can provide funds. One is grants, number two is loans, and number three is prices. Yeah, and all these different pillars are applied to provide, on the one hand, the CapEx for the technology transformation, but also to provide green infrastructure, because it is not only necessary to implement new technologies to produce green steel, you also need green power, and you also need green hydrogen for the reduction. So all these things are funded with multi-billion euro budgets from the European Union to make things move. And here you can see an overview about the spend in different projects. In Germany, the German government, in addition to the European government, and that's the second, let's say, source of funding, they made a so-called steel industry concept, which includes a budget of around 9 billion euro for the steel industry transformation that shall be provided directly to the companies to cover the capex and also the higher production cost for a certain period of time. Here you can see which of the funding is already approved. We are talking at the moment of a total value of about 10 billion euro for 6, 7, 8 companies, which will support their transformation projects. We will look into that later. So what I want to say is this is not just theory, it's already happening. So the money is approved, the money is partly already paid, and the projects are in construction. The latest one was the conversion of Dillinger Hütte just a few months ago. This is an integrated steel company located in the west of Germany. They have 2 plants producing long products and flat products, and they became a funding of about 2 billion euros for a total investment volume of 4.6 billion euros. That gives you a relation of the share of the public funding compared to the company funding, and shows that still the efforts taken by the companies are very high. Okay, then there is, beside public funding, also the possibility for private funding. One example is a greenfield project in Sweden that was called H2 Green Steel. Now the company is renamed to Stegra. For whatever reason, we don't know, but the plan is to build a 5 million ton flat carbon producing integrated facility based on hydrogen reduced DRI, electric arc furnace, and then casting rolling facilities and hot rolling, cold rolling, and also galvanizing. So this will come into operation latest in 2025 at the end. We will then see how this works. So the private funding here was that's supported from public investment funds, and it was a quite remarkable total amount of money they could acquire. It was about 4.5 billion euros they got from private sources. Yeah, let's talk a little bit about production cost. What is driving the production cost for existing facilities, and how is this compared to the future facilities? Here you can see the development of the CO2 certificate market price over the years. At the time being, it's roughly close to 100 euros per ton of CO2. Now, when you just think about that for steel production today in integrated mills, you have an emission of 2 tons CO2 per ton of steel. You can imagine what the price of these certificates is increasing the cost of the production. The public price is different, and this difference then is plausible because at the moment we have a so-called free allowance of certificates. So there is a public price, but these certificates for the public price are freely given to the companies. These total amount of certificates will be reduced over the time, and latest at 2030, the free allowance is at 0, and then the companies have to pay the full market price. So the message is, over the years, the production cost for gray or black steel will increase in the worst case by 200 euros. The big fear here is carbon leakage. What is carbon leakage? Carbon leakage is that black steel or gray steel is imported into the region of the green steel. Yeah, and then of course, when you don't have the burden of the certificates and the transformation, then you can produce for lower cost 200 euros less. And if this steel can be imported into the region, then of course the local or domestic producers have a competitive disadvantage. This shall be blocked by the so-called CBAM mechanism. What is the CBAM? It's the Carbon Border Adjustment Mechanism, and it will, let's say, compensate. So at the end, it's an indirect import tax to compensate for the difference in the price of the CO2 certificates from abroad compared to the Europe. I made some calculations based on published cost calculation tables you can access in WW Steel on the net. And I modified a little bit just to demonstrate what is the cost level in comparison. So for BOF, it is between 690. Of course, it fluctuates. This year, it's a little bit lower. But let's take this status. This is from 2023. So at that time, it was 692 for the BOF, and it was 660 for the EAF. There is usually always a difference of about 5% between the two. Sometimes EAF is higher, sometimes the BOF is higher. But what I want to show you is when I now modify this calculation by putting hydrogen into the game in the direct reduction, then I come to 850. So you can see the cost difference in the production is about 200 euros per ton. Yeah, all companies have introduced green brands in the meantime and try to sell these green brands on the market, which is not so easy. A lot of companies have agreed in contracts to purchase green steel, but the contracts are not effective because green steel physically is not available. Yeah, and the question, how much green steel will be consumed from the markets is also open at the moment. The forecasts are at 25 million tons in 2030, which is about the value or the level of the material which is available on the market at that time. Yeah, regarding the challenges, we have the problem of energy availability, of hydrogen availability. We have the problem of qualified scrap availability and pellet quality availability for the DRI. This is all related on the one hand to, let's say, the level of CO2 emissions on the one hand, and on the other side, on the capability to produce, let's say, high qualified steel grades. Yeah, then I have also a lot of slides for the technologies which are applied, but we are running out of time, so I have to cut the story short. Let's simply discuss two aspects, which is related to the green steel production technology based on EAF and DRI. You have three challenges. One is the carbon control, second is the nitrogen control, and third is the phosphorus control. Yeah, and all these topics are disadvantages in case of the electric arc furnace. And the technology is theoretically available, it is possible, but practically it's not tested. Also, the control of the losses in the process is a topic. Let me come to an end. We have several options to implement green steel technologies. I don't want to go to the details too much, but end of last year, I was personally very optimistic that the train of the transformation is moving and that we will be able, with the new technology, to solve also the challenges which are coming up. In this year, the picture is a little bit different because a lot of doubts have been raised just in the last 12 months. The one problem that's coming up is that the economic situation in Europe after the start of the Ukraine-Russian war is in a downturn. Yeah. At the end of the day, the question is, from where shall we get the money to make all this transformation? So this is doubted. The other thing is that the society is not any longer looking so deeply into this topic of the climate change anymore. So other problems like immigration, like the war, and the economic situation are coming over the topic of the transformation. Yeah, and this is all raising doubts, and it seems that this train of the transformation, which was moving or start to move, is now running into a heavy inclining section and is losing the power. In my opinion, the first round of investments, which are already confirmed, will be done. But what happens with the second round and the full transformation today, we definitely don't know. So this is the end of my presentation. Sorry that I had to jump over the contents a little bit fast, but you have the opportunity to read it when you download the PDF. Thank you very much.
Thank you, Dr. Kappel. I mean, you already answered two questions which we are asking the same content of the last part of yours. What is now about the future of green steel and how it will look like, especially after the postponements or the announcements happened by ArcelorMittal and ThyssenKrupp that delays in their projects will happen. So, and you answered now, or you raised the topic now that the war and all these other external parameters were really a reason for such recent decisions. And apparently, yeah, we can see that milestones announced will be postponed. But yeah, this is part of the game. Yeah, thank you, Jürgen, for your presentation very much. We are very glad to have it. We have good material as well for all participants, so they are really also they can go through it, and if they have questions, of course, they can come back to you. So thank you again. Let's go for the second presentation. So we have with us now Paolo Stagnolilli. Paolo is an Italian by birth. He is working for Tickent Group since 1996. And from starting with 2008, he joined the sales and he became the sales and marketing director for the melt shops of Tenova. He operated in the steel making sector since 2004 as a project manager and after sales manager. He's an author and co-author for several technical papers in recent years, mainly in advocating the transition towards more sustainable, economical, viable steel making. He's passionate about technologies, curious about people, confident about the world to come. Very nice. The floor is yours, Paolo. Excited to hear you.
Thank you for the show.
Thank you.
Thank you for the show, and thank you again for having me. So my presentation will be, these days are complicated, meaning that we as Tenova, we are entangled in a series of non-disclosure agreement, which will prevent to, of course, share with you the most juicy part of the things we'll be discussing, but to some extent, I would like to be present to you at least our general point of view on what is going on. Mr. Kappel has already presented something about the general situation. The scenario is very complex. Everybody's still talking about everything, but there are some factors which have caused initially in the past year, in our view, a hype for the hydrogen, meaning that most of the steelmakers consider the green hydrogen as a marketing factor, but the technologies behind enabling the revolution to green hydrogen were not applicable. There were no technologies scalable up, and the arrival of high quantities of green hydrogen is subject, of course, to the availability of a very large quantities of electric energy, also green. And what is happening now, from our point of view, we can confirm that most of the projects, if not all of them, which entailed installation in Europe, but possibly one or two projects we are aware of. One is Salzgitter in Germany, which is forging on. There is Holland, which still has very good perspectives on installing the DRI plant in IJmuiden. But basically the announcement of ArcelorMittal, the crisis of the ThyssenKrupp project, and some other hints we got from Northern Europe point to the same general effect, which is DRI plants in Europe are a very hard sell for the moment being, because hydrogen does not exist yet, and the cost of the natural gas for our countries is killing. You can say that most European countries, if not all, are all on the right side of this graph. We are talking about the costs which are 10 times more than the cost of the natural gas in the countries where the natural gas is also is produced. And since now everybody seems to assume that the way out of the general energetic crisis will lie with nuclear power, but nuclear power plants require a significant amount of years, or as they always have required, to go online. We will need to wait another possibly 15, 10, optimistic 15 or 20 years. So what is happening now is that a lot of projects are going on, which is for real in all the Western world, but most projects are focusing on the steel making rather than the iron making. I avoided most of the commercial reference here, but I just can talk about what I know about, which is we started doing stuff demonstrating that electrical furnaces for flat steel were possible with Arvedi. Arvedi is producing simple, comparatively simple grades, but based on that experience, we had several contracts ensuing. The last one signed contract, it's Tata Steel Port Talbot. I can talk about that because it was on all the newspaper. They are the trend of the very large furnaces, very productive, is continuing. We have several other projects ongoing with customers urging us to produce even more productive plants. So Arvedi is producing more than 400 tons of liquid steel per hour. England, provided that everything goes according to plan, we go for 430. And there are other Western players, no, Eastern players, which are asking for even more. So the trend is consolidated. The trend in Europe seems to be based mostly on the obsolescence of the productive assets. When the time for the relining of an old blast furnace comes near, the steelmaker has to take a decision. Most of the steelmakers facing this decision in Europe are deciding to kill the blast furnace and go for something else. Then the next decision is what to do and to what extent to push the integration upstream, because every producer of high quality steel grades knows that it's impossible to produce high quality steel grades with scrap alone. Scrap, as of now, it's impossible to remove chemically the copper, for instance, or the tin from the scrap, from the liquid steel. There are studies being done of electrolytic processes to remove carbon and copper.
Small interruption. Yes. Somebody is asking, interested to see the figures more clearly. If you can be enough with your video apps on the top, so you can just remove that you are to be also as a part of the screen.
Sure. Sorry.
Yeah. Thank you. No, it's okay. So that they can see it better. Thank you.
Yeah. Okay. Anyhow, don't worry. I will be sharing this presentation again in PDF, so you will be seeing it all. Okay. I'm just sharing the screen now.
Now we see you. We need to see the Excel sheet.
No, that's okay.
Thank you.
I just was excited about this brand new feature of no, this is not this one. I'm sharing the wrong one. Will discount against my 18 minutes.
Yeah, no, it's okay. Go ahead.
So, this one is the good one. Better now?
Yes, thank you.
Okay, so you see that we are studying stuff, possible processes, electrolytic processes to remove the copper and from the liquid steel. We think that the scalability of those processes, which work just fine on a lab scale, will come into 10 years from now. As of now, if you want to produce clean stuff, this study on the right was done for an Italian steelmaker willing to produce rails. For some grade, they needed to reduce the copper content to less than 500 ppm. And you see that the only possibility with the scrap grades available on the Italian market was to use almost 80% virgin iron units. But also our cousins in Ternium for the Pescheria project, on average, will be using 60 to 70% virgin iron unit coming from, well, hot DRI to achieve the quality of liquid steel they need to satisfy the requirement of the users. Also Arvedi, even though they don't produce in interstitial free nor electric steel, they use a significant quantity of HBI and other virgin iron units to close the balance with an acceptable content of copper and tramp elements. And there is also another side effect. Mr. Koppel properly mentioned the content of nitrogen. The content of nitrogen is critical for some steel grades. For instance, as I mentioned, interstitial free for exposed body parts and electric steel. The first and foremost evidence is scrap brings in nitrogen. The study on the right comes from one of our plants. You see that in spite, there is a very solid trend of decrease of the nitrogen content with the increase of the virgin iron unit. The graph is executed between 0% DRI and 80% plus DRI. You see that I would say that whereas scrap can bring in up to 100 ppm nitrogen coming from many sources in scrap, DRI is likely to bring in 20 to 25%, 20 to 25 ppm, dissolved nitrogen, which is also a factor that points to the fact that high quality steel cannot do without a virgin iron unit, which is why the steelmaker would like to integrate upstream. But there are different factors, there are several factors pointing out to the fact that this is going to be difficult in Europe. First of all, cost of the natural gas, waiting for nitrogen, running a plant, waiting for the green green hydrogen to come, and hoping to have an operating expenditures enough, low enough to stay on the market is now kind of difficult. And there are also other issues, like Europe has no reserves of iron ore except in Sweden, very good reserves. And then there is the topic which was mentioned also by Dr. Kappel, of the availability of high quality iron ore. Another evidence pointing out to some issues with the future supplies of DRI and pre-reduced materials is that the market of the DRI nowadays is in the range of 100 million tons, 120 million tons of DRI produced. Most of those tons are produced and consumed within the producing country, but we are trying to compare a market worth some 100, 200 million tons of DRI with a market which is the market of the competing market of the blast furnaces eventually, which consumes 1.5 billion tons of raw materials, if not more, 1.7, I would rather say. So the many issues are pointing towards a lack of available technologies. Up to us coming to the producers of steelmaking plants, we can get to the quality desired. Several customers already, as I was showing to you, have decided to go for an electrical furnace because we managed them to convince that under certain conditions they would have been able to produce the quality of product they want. And if you are interested, you are very welcome to ask for your case if you are a steel maker and get a quotation from us at large. But still, many issues are there. Another big issue is that if it is true that the R grade, so high quality iron ore concentrates, will not be available in the future, and this comes from the nature of the iron ore which is extracted from the mine. I was talking with an official from a very large mining company last year. He basically told me that with the quality of iron ore he was extracting from his mines, beneficiating them to the point that they qualified as DR grade materials, would have meant losing 50% of the iron ore extracted to the tailings of the mine, which is of course not acceptable. And then there is a common misconception that electrical furnace cannot deal with BF grade material. Of course they can. The electrical furnaces can melt pretty much everything. The issue, the real point is if one thinks to charge 100% the blast furnace grade pellets, which have high gangue and acidic gangue at that, into an electrical furnace, closing the process in a way like the one depicted in this graph, which points out to the production of flat steel. So you see that in the liquid steel, the carbon content is 0.035, and so on and so forth. Tapping temperature is also consistent with flat steel production. One ends up with a huge quantity of slag. This is by operating the EAF in the normal way, okay? So starting from the R grade pellet, injecting oxygen to remove, blast furnace grade pellet, injecting oxygen to remove the excess carbon and to remove the phosphorus, adding to the process lime and dololime enough to protect the bricks and to achieve a basicity index of the slag sufficient to the phosphorus removal, one ends up easily with a quantity of slag which exceeds by far 300 kilo per ton, even 350. And since an electrical furnace is working to produce such a low carbon product, 40% more or less of the slag due to the chemical equilibrium in the reaction and to the kinetics of reaction is iron oxide. One ends up losing to the slag a terrific portion of the iron which has been put into the furnace, in turn producing a kind of slag which unfortunately by containing 40% iron oxide is nothing but waste. So one of the material issues is that the blast furnace-based plants now operating nowadays look at the slag as a source of revenues, because the slag produced by blast furnaces is something which is interesting as a raw material for the cement industry. Remind that the cement industry is one of the largest sources of scope 1 emissions. When they burn, when they calcinate calcium carbonate to produce lime and to go on and produce clinker and the rest which is needed to produce the cement, they release vast amount of CO2. So being able to sell to the cement industry a product which can replace some other chemicals which come with a high CO2 bill is very interesting. So besides the issue of finding ways to produce steel from subpar quality materials, there is also the issue of producing a slag which is marketable. There are already, and we developed already for several customers, specific processes on how to deal with blast furnace grade materials and producing blast furnaces like slag, which can be turned downwards afterwards in clinker, for instance, for several customers. This is an example. You can have a look at the input and at the outputs of the process. This kind of process requires a specific design of the electrical furnace and a specific design of the refractories too, and I hope I will have the chances to discuss this with our AHI colleagues anytime soon. The slag can be treated. We already have examples in the world of a dry slag granulation that turns the slag into a vitreous compound that has several advantages, including the fact that it does not release leachates, and it is very stable and can be sold as a product to the cement industry. To summarize it all, I saw you, Karim. This is the 30 seconds. Transformation is now being redirected in a way. The European steelmakers seem now more willing to consider the installation of the electrical furnaces alone, under the assumption that you can produce good quality stuff from the electrical furnace. But this brings in the necessity to find the sources of virgin iron units coming from somewhere else, which is a trend which is already being considered by several players who have announced very large projects of production of DRI and HBI in Middle East, or in Libya, for instance, in Oman. There are several projects ongoing, which will in turn open the possibility to split the value chain in different ways. Like, low quality DRI is a proxy to high energetic consumption in the plant that uses the low quality DRI. So why not to turn the low quality DRI into high quality metallic material by shedding the slag in a plant which is located in the country that has a low energy bill. So the value chain is being now rediscussed and rehashed. So we, as producers of technologies, we are facing a shift of the needs from the traditional needs of melting stuff and going on with the quality of the steel alone, towards usage of novel raw materials and the valorization of the slag to overcome the needs of the cement industry. And thank you very much. Any questions?
So thank you, Paolo, very much for your very interesting presentation. It took us to more technical depths about the challenges we do have in producing, let's say, green steel. It's not only about now DRI grade pellets, but now in some years it will be a topic how to substitute this or how to cope with low grade pellets in order to sustain our productivity. I see also, or I agree with you that there should be some flexibility here in terms of optimum locations of steel plants.
Exactly.
Now, totally, as you said. So it is here about the green energy, where we can find the green energy, cheap green energy, not only about energy, but cheap ones. So we should also, as a steel makers or as investors, think differently now. It's not all in Europe hands anymore if we want to sustain this production or this industry.
Some might have noticed during the last conference in Dubai that there was a potential customer of ours which was having some novel idea of a product, because it takes 2 to 3 years for a steel making plant to qualify for the production of interstitial free grades. So in Europe, we surely have the competencies on the quality of the finished products, and we have the using industries. This is something that would be worth leveraging. But we have a very high energy cost to the moment when our entire energetic infrastructure will be transformed. Whereas in other countries in MENA, there is the opposite situation. There is easy access to a resource which is very much an asset, which is the energy. And on the other hand, could be difficult to begin producing high quality steel and certifying it if one has to wait 3 years before he can sell the good quality stuff to car makers or to the electric steel makers, which is why this kind of project, splitting the value chain at the point of the virgin iron units, are popping up quite consistently in both in Europe, where many are thinking at the electrical furnace and secondary metallurgy alone, and in the Middle East, where many are thinking about exports of HBI or similar products.
Well, Paolo, thank you very much. We have one question, but we are already late, so maybe we can answer it later at later stage. It's about your opinion about the smelter, because you said in one of the slides about the smelter. How? So
I will type the answer.
Yeah, please. Perfect. So let's go now for our third part. So I'll share my screen again. So now, I hope everybody sees my screen. Sorry. So now we are switching to Joachim from Chile. Very happy to have Joachim with us today in this webinar. Joachim has also very rich CV. If we can go briefly through it. So he's a global director in Linda. He has been working with process and manufacturing industries in steel, minerals, and metal production, but also in automotive and chemical sectors. Joachim joined the industrial gases industry in 1996. Since then, he has served in many different technical and commercial management roles. At AGE, BOC, and Linda, has been actively doing business in more than 40 countries around the world. After a decade in Asia, first in India as a vice president of South Asia, and then in China, heading the application development of sales Asia Pacific. He is since 2020 based in Munich, Germany, pursuing his career role at Linda. Joachim has published more than 200 papers, mainly in energy, emission conversion, recycling, production, and he authored chapters in 5 books. He has served as a member of more than 30 boards of companies, associations, and research and education organizations. Thank you once again, Joachim, for having you today. Please start your part. Thank you.
Thank you very, very much, Karim. It's a great pleasure to be here. Marhaba. Hi, everyone. And I will see if my presentation can come up here as well. Yes.
Not yet.
Yeah, I'm on my way. Let's see. Are we there now?
Yes, please.
Good. So, nice to be with you, everyone. And let's talk about green steel projects, challenges, and opportunities. And I will have quite a strong focus on the MENA region. So it's looking at Northern Africa and Western Asia when I think about these kind of things. And you might wonder why is a guy like myself here? Well, I'm working with Linda. We work with gases, of course. But that's not only these oxygen and nitrogen and argon. So we also work a lot with hydrogen. We have worked with hydrogen for more than 50 years. We are probably the world's leading supplier of merchant hydrogen, with sales of more than 3 billion. Another factor here, which might qualify us for this discussions, is that we are quite a big provider of different technologies for the steel industry. The most famous one back in time was the AUD converter, but you heard perhaps about Cojet, Reebox, Oxygon, etc. So we work a lot with the uses of the gases in the steel industry as well for different things. Now, let's look at what is happening in the world and let's zoom in a bit. Where is the world steel production today and where is it going? And I was contemplating at the end of last year, at the turn of the year, and the formation of what we can call BRICS Plus. What is the size of BRICS from different perspective compared to G7? And if we just look at the last line in the table to the left, you see that the G7 countries, they produce about 16% of the steel in the world, while BRICS or BRICS Plus produce about 2/3. 2 out of 3 tons in the world is produced in the BRICS countries. And if we then look at DRI production, which is something that is coming very much into focus when we talk about green steel, and of course we talk about natural gas-based production, not so much about the coal-based production, which is predominantly taking place in India. We can see that the enormously important role that the MENA countries have in this context. They're absolute dominating in the world. And that creates a fantastic basis also, of course, for developing this further. And I think that we can see estimates that in the next 15 years, there will be roughly a doubling of the DRI production in the world. And I would assume that the vast majority of this development, this doubling of DRI production, is not taking place in Europe, but maybe more in the MENA countries and some other places in the world. And if we assume now, and I think many could agree to that, we will see an average growth of the steel production in the world over the next, say, 15 years, so about 1% or so. This is not very much to be taking place in Europe or so. I think we can neglect Europe very much in this context. The biggest growth is happening in India. Yeah, and basically, if you see a growth of, say, 300 million tons a year, about half of that is taking place in India. But looking at the MENA region, I think we are forecasting roughly a doubling. So that is very, very good news. And I think that has its reasons also when we talk about the green steel. One thing that we always should remember when we talk about green steel is the availability of scrap. And I think we can see that the world's largest producer of steel, China, with more than half of the world production, will have quite a reduction of its CO2 emissions. And part of that is due to the higher scrap input that will be there. But there will also be a little bit less production in China, as we've already seen. And of course, a number of good things when it comes to technology is also being implemented there. MENA, we have seen pictures like this. This is taken from IEFA. Examples of new plants that are coming up in Northern Africa or around in the GCC countries. And this is just one example of such a summary. There are many others, and there are also people here today that will talk about these new plants. So I think that we see a lot is happening because there are very good preconditions for making steel, and not at least to make green steel in the region. And I dare to say that we are looking forward to having the MENA regions as a future powerhouse for green steel production. And taking that in the perspective of Europe for a second, and it was talked about Europe a bit in the previous 2 presentations. I borrowed this diagram from my friend Rutger, who published this in Steel Times in October. And you can see, if we consider hydrogen to be a key for green steel production based on DRI, you can see that the importance here of the cost of electricity and how that impacts potential production of DRI using hydrogen in Europe. It's quite high compared to if we produce it elsewhere and using natural gas in the MENA region, for example, as mentioned here in the diagram. So DRI production from natural gas is way more competitive than DRI production from hydrogen in Europe. And that can open up for different scenarios, of course. We should keep in mind here, as I noted, that a large part of the cost to produce hydrogen is the cost of electricity. It's more than half of the cost. So when we look at different vehicles for steel production decarbonization, I think we should take a bottom-up approach and start by looking first at energy efficiency. What can we do to use less energy in the production? And oxy-fuel combustion, and particularly with hydrogen, is a good thing there. Second thing is to look at other alternative fuels. So now I'm looking at fuels here mainly. And then we have two things that are more connected to the reduction part in general. One is the CO2 capture, and the other one is hydrogen, and hydrogen then for the reduction. We should keep in mind hydrogen can be used both as a fuel in the steel industry and for reduction. Many people are not considering maybe enough the possibilities to have a decarbonization or a direct reduction from natural gas-based production using carbon capture. We think that that is something that we will potentially see much more of going forward. Of course, we can use hydrogen there, as many people discussed and in previous presentations, but there is also the opportunity to capture CO2 coming out from the DRI production, and that is already done actually. So we have so there is a removal of CO2 from the process, and that can be done with a very high degree of efficiency. And I think that particularly in the MENA region, this could be a very interesting solution to do carbon capture from existing and new plants that are using natural gas as a reductant, and potentially then phasing in use of hydrogen. This is not new technologies at all. If you look across the world, carbon capture today is about 45 million tons of CO2, and a number of installations are operating since quite long time in the steel industry. Here's an example of so-called high salt technology, and which is in this example is installed at the Corex plant in India, and the flue gas volume there is 500,000 cubic meters per hour, 500,000 cubic meters of flue gas per hour, and about 95% of the CO2 coming in that stream is actually captured. When we look at hydrogen in this context, I think we again should be very agnostic about how this is done. I know that our friends in Brussels have had a little bit rigid approach to it and talk about only electrolyzers, but to being successful, I think we should be more agnostic. It's important that we consider all alternatives, and as long as we are reducing carbon footprint and making greener steel, I think that we can embrace all of them. If we look at the electrolyzers, most people talk about so-called PEM electrolyzers that are more flexible when it comes to the electricity supply, or the variations of the electricity supply, better say. So it fits better with solar and wind power supply then. So far, however, the PEM electrolyzers are comparatively small. The biggest one in operation is 24 megawatt. We will see 35 megawatt next year, 100 megawatt the year after, or so on. But there's a need for a scale up, because we will need say 500 megawatt electrolyzers for the steel industry, or more bigger than that. There are alkaline electrolyzers as well around. They are bigger, but they have less flexibility. So there is a need for the scale up of the size, but there also a need for the scale up of the manufacturing of the electrolyzers, which is rather limited today. And we are expecting a doubling in the next 5 years. Still, that is much less than what is required according to the plans that have been outlined for many countries. An alternative to that is to use SMR or ATR technology, where you feed in natural gas and capture the CO2 that is done in the production of the hydrogen from there. And this has developed a lot over the last few years, and we see that many times as a good solution at very large scale here. So that is an opportunity, and it's important that we think about what is the best way to scale this up, and it could also be in a transition, of course. If we compare a low carbon hydrogen production with different technologies, we can see that if we use natural gas based and a carbon capture, we are today having plants at large scale, more than 200,000 tons per year. We are investing in a new plant, Linde, for example, of that size in Canada now. That is the equivalent of 1 gigawatt electrolysis, which is of course much bigger than what is in operation there today. So this could be a very good way to supply hydrogen. And that hydrogen actually could have a very low carbon footprint. We talk about 1 to 2 kilograms of CO2 per kilogram of hydrogen. If we compare that solution to having a carbon capture from multiple points in a steel plant, I think this is much more efficient way of doing it and using hydrogen than as a reductant and fuel in the steel plant instead. We have looked at this. I will not go into details of all different numbers here, but I think that we can see that from a cost perspective, to have a DRI production coupled with EAF plants, it looks quite attractive to use this type of supply solution when using hydrogen here. So I think that is something that should be more discussed. As many people always emphasize, it's about various solutions. It's a toolbox and a combination, and we have to be open and evaluate different ways to reach the ultimate target of producing green steel. And I see this fitting quite well in Northern Africa and GCC countries, etc., in West Asia, where there is also quite good possibilities for storage of CO2. Another thing is the low carbon fuels of different kinds, which we see coming up at many places, and that is then used for a generation of a syngas that can be used in a blast furnace or in a DR shaft as well. That could be based on gasification of solids, liquids, and gases. There are various technologies. Here's one example, the so-called hot oxygen technology. This has been tested in various scales, also with DRI, for DRI production together with Midrex. And one example here is mentioned is for converting municipal solid waste into sustainable aviation fuel. This is from the US, that picture. This is also something that is possible here to use in the steel industry. Now, looking at the melting and heating operations, then now we are back with the energy efficiency very much here. So if we can go from a conventional, traditional combustion with the fossil fuel and air to an oxy-fuel combustion, there are good possibilities to have big fuel savings and thereby also reduction of the CO2 emissions. If we do that conversion in such a way that we implement the technology that is hydrogen ready, then we can of course replace the fossil fuel later on with hydrogen, partly or fully. And we can take a step where we maybe reduce the fuel consumption and the carbon footprint by say 30% in the first step by doing these kind of things. And this has been going on for quite a couple of decades now, the first part of this, with hundreds of installations across the steel industry in various processes. Traditionally, of course, oxy-fuel combustion came into the electric arc furnace to support the melting, and the cojet technology has been there since 1996. What is interesting is that there have been the first operations and tests using hydrogen there for the flame shrouding for the oxygen injection for the cojet injector, and that has worked out very, very good. So, and it even gives a better operation than with the other type of fuels there. So that works, and it even provides additional benefits, I would say, with the longer injection jets. When we look at combustion, we should distinguish between the conventional oxy-fuel like used in an electric arc furnace and the flameless oxy-fuel types, which is used for heating and reheating, where instead of a very hot and sharp, bright flame, we have a flame cloud with a very uniform temperature is then heating ladles or heating slab sets or billets. So this has been implemented now since about 2 decades in various installations with very, very good results. We have been working a lot with this ourselves, as you can see examples of here. And also in hybrid solutions where it's a combination of air fuel and oxy-fuel, and this has become very popular over the past few years. And we see that a lot of the new installations here are actually happening in Asia. You see examples of what is to be commissioned with this technology here in India, in Thailand, and in Turkey. There is also examples of heating using only hydrogen, 100% hydrogen, 100% oxygen with 100% hydrogen. First example of this was already 5 years back at Ovako Steel, and that is now in full-scale operation since let me see, what are we now, in 9 months ago. So this is in operation. This is not futuristic. This is today, 100% hydrogen for steel reheating. And we see a lot of things going on following that diagram that I showed earlier. And here is an example from Finland 2 years ago, converting a 75-ton walking beam furnace first into flameless oxy-fuel and then making it hydrogen ready. Similar stuff going on at other plants like Ovako Boxholm and in the US. Ladle preheating, I already mentioned, very good opportunities to reduce the fuel consumption there as well. So I see in general that we are moving into what the near-term solutions that are more improvements of current processes before we go into the more of the mid and long-term things coming in the next decade. Trying to summarize a bit there, it's very much about emphasizing energy efficiency. It's about remembering the possibilities for carbon capture, both from the processes and for when producing hydrogen. Many people already pointed out, and also in the discussions here, the importance of the electric power supply. If you build a new plant, it might cost much more to secure the electric power than the plant itself. Particularly, Paolo talked about the different grades of iron ore and the limitations that could have. So it's the same thing. It's important to pay attention to scrap here. I think that when we look at the supply of hydrogen, which is more of stopping us today than the technology as such, it is about the scale of the supply, it is about the possibility for carbon capture, and it is about the availability of electricity supply, particularly then, of course, renewable power. And with that, keeping that in mind, again, we see very good possibilities for the MENA region, for sure. And let me emphasize that hydrogen is very tricky to transport. So hydrogen should be produced where it is to be used. If you want to transport something, why don't you transport the HBI? Or why don't you transport semi-finished products instead of trying to produce hydrogen? I think that this altogether creates the possibilities for the MENA region to be a true powerhouse for green steel production going forward. Thank you very much for your attention.
Thank you very much, Joachim, for a very interesting presentation, as usual. It gives good insights about the gas industry and how you are always trying to be up to the maturity level of the steel industry. Well, I totally agree with you that the thinking in Europe should also change, talking about proper ways to transport green hydrogen from Middle East to Europe by pipes or through methanol or through ammonia. Isn't it another mature option to produce the HBIs, DRIs, the green ones, use them as a green hydrogen carrier? And let's continue the value chain downwards in Europe. I think this is really a very mature thinking, but and we see that some understanding started to happen, despite that there was always resistance in the past 2-3 years. But it is now, some let's say, understanding is taking place in Europe that a part of the game should be done here in the Middle East. I have one question. Maybe, yeah, the thing with that everybody is talking about green hydrogen or green steel in 2-3 years start up. And just for everybody to imagine, producing 2.5 million ton DRI facility, which is nowadays standard module, you need 1 gigawatt of electrolyzers. So, and on the other hand, we see everybody is talking about small electrolyzers, 10 megawatt, 15 megawatt. How easy in 2-3 years that everybody will manage, not everybody, but the people who are now ambitious to produce in 2 years green steel, how they will manage to reach this maturity level?
It is very simple. It will not happen. We should be honest.
Oh, yeah. Okay, this is please.
I mean, we haven't seen it proven. If you look at the alkaline electrolyzers, there are alkaline electrolyzers in operation at about 100 megawatt to up to towards 200 megawatt. That is possible, and you can add a number of them, of course. Of course you can. Also, if you look at the electrolyzers are built in modules, but it needs to be scaled up, it needs to be proven, and so on and so forth. I think that people are. I always try to be optimistic, but I try to be realistic also, Karim. So I think that we need to be careful with that this is happening. It will happen, but it will not happen as fast as people hope it will.
Totally agree with you. Thank you, Joachim. Very big thanks for you.
My pleasure. So thank you.
Let's switch now to our. Yeah, so do you see my screen? I hope so. So now we have Mohammed Saleh. We are very happy to have him for the first time with us in the chapter. Mohammed Saleh is a young engineer, now a good manager in AM Steel in the field of environment and sustainability in Emirates Steel. Mohammed has 13 years of experience in steel industry. In his role, he is responsible for environment and sustainability performance, compliance, risk assessment, training, and monitoring. He holds a master's degree in environment science, bachelor in chemistry, along with certifications as lead auditor for ISO standards, environment management, energy management, and health and safety management. He is also NEO-BOSH certified in environmental management, and he has a wide experience in sustainability, GHG, reporting frameworks, including many other certificates. We are happy to have you, Mohammed, with us today. Please share us some insights about the great steel plant, Emirates Steel. Thank you.
Thank you, Dr. Karim, for this introduction. Really appreciate your invitation, and thanks all for allowing me this opportunity to discuss today with you about Steel or Emirates Steel green steel journey. Over the next 18 minutes, I will try to be a little bit optimistic, unlike my other colleague, but I would like to present what we have done so far in terms of decarbonization efforts in Emirates Steel. So please confirm if you can see my screen.
Yes, we see.
Can you see my screen?
Please go ahead. Yes.
Thank you. First, I would like to give a small introduction about Emirates Steel or MS Steel. MS Steel is the group company of two business production streams, Emirates Steel and Emirates Cement. We are a group of 4 companies, actually. Emirates Steel, Steel Business Unit, Emirates Cement, Blocks, and Anabib. Our total production of steel is 3.5 million ton, long product, rebar, wire rod, rebarring coils, and also heavy section sheet piles. And also we produce 4.6 million ton of cement annually. We are integrated steel plant. We are natural gas-based DRI. We have 3 modules of the Dinova, HYL, DRI production units with production capacity 4.2 million ton, and we have 2 steel making plant with 3.6 million ton capacity, along with 5 rolling mills with total capacity 3.5 production capacity. And before we delve in the details, I would like to emphasize on the challenges that my colleague presented. And we also, in MS Steel, we have a very ambitious target and journey to decarbonize our facilities. I will not give more details because it's already Dr. Jürgen presented the challenge in terms of the required carbon emission target and from steel industry to be cut by 55% by 2050. By 2050. As my colleagues mentioned, that the maturity of the technology is so far mature enough to scale up or to be sufficient for decarbonize the current steel industry emissions. But I want to emphasize on also the current risk internally, local and external, which is CBAM. So in terms of UAE regulation, we have 2 very important programs so far. The first is the first indices that by UAE government. It's the national target. So the initial target set in 2019 for steel industry to cut their emission by 5%. But after publishing the second indices in the previous scope here in UAE, this target is stretched to 13% by 2030, and also there is aggressive reduction target post 2030. 33% by 2035 and 64% by 2040. And also there is a carbon pricing mechanism is now under discussion, and it's possible to be mandated soon. It will be for sure a mirror for the CBAM regulation. It will be implemented here in UAE. Probably it will be implemented in the energy sector, transport, and industry sector. We are expecting almost $30 per ton CO2 will be imposed on the steel product. So this is also another risk we have here in UAE. But actually, Emirates Steel see this as an opportunity. So we see this risk, it could be turned into opportunity if we have a chance to access a green or to have a green price premium if we are beyond this target, and also it is possible to access some green bond or green investment to support our decarbonization journey. In general, our decarbonization strategy focused has been built on 5 pillars. We have a commitment to reduce our CO2 emission by 40% by 2030. Even the UAE government is asking for 5 or 13% maximum by 2030, but we have very ambitious target. We set 40% by 2030, and also to achieve the near or the net zero by 2050. So our strategy focused on 5 pillars, as I mentioned. The first one, the carbon capture utilization facilities that we already have it since 2016. And also we are exploring the potential for incorporating the green hydrogen in our facilities. We also focus on utilizing clean energy sources, particularly focus on the power purchased agreement or the clean energy certificates, which could be utilized from IREX certificates. We also focus on utilizing more scrap, given that the challenges of the availability of high quality scrap, but we have a very ambitious target for increasing the scrap content in our raw material mix up to 30% by 2030. And in terms of the existing facility, we are adapting high technology, up-to-date technology, and we have a very ambitious reduction plan in terms of energy efficiency. We set 7% energy reduction from the baseline, which is 2019. So we are aiming to cut our emission with these 5 pillars to 40% by 2030. For sure, we have to look for some critical enabler for the supporting us in this net zero transformation. As you may know, we have a good partnership with ADNOC, which is this is the local oil and gas company in UAE, and also Masdar for supporting our journey during through strategic partnership to adapt the new technology of CCUS or hydrogen. We also doing R&D and some technological R&D for the CCUS and green hydrogen here in UAE. We also have a good strategy in terms of transformation. Emirates Steel management leadership keen to implement this transformation starting from ground level up to the higher level. And also we are going to enhance our tracking and modeling of the CO2 tracking data. This is very important to track our emission not only on a yearly basis. We have now some digital system to calculate our CO2 emission per heat level, per product level. So this is online system. So we able to monitor and compare and benchmark, internal benchmarking our performance to make sure that we align our effort with the decarbonization strategy. We also disclosing our strategy. You can find all the details and information in the CDP report and TCFD report, and also in the sustainability report that published in the website, our website. In terms of the emission performance, as you may see here in this slide, our performance, we are consider ourselves as a benchmark for industry, one of the benchmark steel makers and steel industry. Our scope 1 and scope 2 emission is 0.72, which is great number compared to our competitors. And also we aiming to cut this emission by this is our since the implementation of the strategy 2019. This is the performance. So our emission is declining yearly basis. So far we have achieved 28% in terms of the decarbonization targets, and we aim to cut the total emission by 40% by 2040. Also, this year we have a very interesting milestone in terms of the decarbonization. Emirates Steel has launched or inaugurated the green hydrogen power plant, green hydrogen facility in our plant. And the purpose of this project is to test the hydrogen in our existing facility, HYL. As you may know, HYL declared that with the current technology, we can adapt up to 70% of the hydrogen without a capital, I would say, technological change. So we aiming to produce from these facilities up to 5,000 tons of, I would say, low emission DRI. However, as my colleague mentioned, that the scaling of this green hydrogen is come with many challenges. The first challenge is the transportation and also the scale up of the hydrogen plant to feed our existing module. We have the capacity of 3.5 million tons DRI production in our facilities. So also the scale up of this comes with a lot of challenges, but also another challenges exist here is the availability of the green electricity. I would say green electricity. Also, there is a challenge here in UAE because of the power purchase agreement. This kind of mechanism is not allowed here in UAE, but currently there is a lot of discussion and the regulation might be changed in the near future. In addition to that, also Emirates Steel is working closely with Masdar, our partner, to explore the opportunity for scale up this project up to 100 megawatt. And the initial plan for this project to be started in 2028. So we see this is a very critical step forward to test the hydrogen in our facility. This is our first green hydrogen in the plant in the MENA region. Also in our facility since 2016, we have adopted the carbon capture project. Our capturing capacity is up to 800,000 tons of CO2. The basic idea of this, our flow gas is enriched with almost 8% of CO2. So we pass these gases into a separator and we bump these gases, CO2 gases, into the Riada. This is this adjacent facility. The purpose of this facility is to increase the pressure of CO2 and also dehydrate the CO2 and remove the moisture from the gas. And then this CCUS facility is pumping the CO2 enriched gas into oil field, which is located 43 kilometers away from Emirates Steel facility. And using this technology, we are ADNOC, our partner, is able to increase the pressure in the well and also increase and pump out the oil to increase the productivity of the well. So this project is proven, and we adapted this technology since 2016. Last year, we able to capture almost 500,000 tons of CO2, and we are aiming to increase the captured amount to reach the full capacity to 8,100 tons of CO2 by 2030. In terms of the clean energy, we are using clean energy certificates to reduce the scope 2 emissions. So so far we are last year we utilized almost 84% of clean electricity certificates. The majority of this certificate is nuclear, 62%, and for the solar energy is around 22%. By the way, this amount is equivalent to 2 million megawatt hour of our electricity, which is 84% of the total electricity used here in Emirates Steel facility. And we have ambitious target to adapt 100% of clean electricity sources by 2030. And also we are now in discussion to invest in PPA project to have a solar power plant dedicated for our facility. This is currently under discussion with the government, and soon we will see how it will lead this discussion. In terms of the scope 1, we have, as I mentioned, carbon capture, and also we have energy reduction plan, and also scope 2, we have the clean electricity. There is also one aspect need to be addressed in our decarbonization in our decarbonization strategy is about the scope 3. Almost scope 3 represent 40% of our total CO2 emissions. So we are giving this amount high importance as well, like scope 1 and scope 2 emission. So this year we have a good partnership and strategic approach with one of our partner, which is called H-Carbon. This strategic partnership give us the opportunity to access and communicate with our supplier to get the available CO2 data, and also there is active discussion with our supplier to reviewing their decarbonization efforts. And also we are offering a training, comprehensive training to our supplier about the aspect of the CO2 emission, the taxes, and all of this aspect could be collaborative with our supplier to reach a good position in terms of reduction the overall scope 3 emission. Also, since 2021, Emirates Steel has think differently in terms of the sourcing of the IOP materials or iron ore pellets. We have took a very proactive step to prioritize our raw material sourcing from the nearest location. So as you may see from this curve, we're changing the mindset of sourcing our IOP, and we started to import our material from the nearest location, especially Valley Oman and Bahrain Steel, which represent together the 75% or 76% of our total IOB material consumed in our facilities. And also we are considering also their impact or their emission as part of the sourcing behavior. Also, given that the current challenge or the future challenge for the availability of the IOP, high quality IOP, especially if the current project in Europe and all over the world regarding the operating the DRI plant will start up, it will make more pressure and challenge in terms of providing and supplying high quality IOP. So our management take a very proactive step, and currently there is a discussion is actively with Japanese and Asian partner to build a joint venture project here in UAE. This project will be a complex to produce the high quality IOP, HPI, and DRI. So with this project, we aim to secure our future supply of the high quality iron ore material. I cannot disclose too much information at the time being, but this project will be announced soon. Maybe in the first half of 2025, our management announced in this partnership, and also this project expected to be in operation by 2028. So this is also our decarbonization plan in terms of the supply chain. So we have a good shape of strategy in terms of decarbonization our scope 3. So this comprehensive plan contains training to our supplier, and also I would say evaluation of our supplier based on their performance in terms of the ESG and sustainability performance. So this is the ESG performance that we implemented this year in terms of the supplier. So we will classify our supplier based on the score that they will collect from the questionnaire, and we will classify our supplier into 3 categories: low, medium, and high risk. Supplier with low risk will be given 2 years plan for improving their score, and also their CO2 emission performance will be part of this performance. To wrap up and conclude my presentation, I would say we are proudly ahead of the schedule of the decarbonization plan. So far, we achieved almost 30% reduction of decarbonization plan. Thanks for the the current technology that we have already. We are lucky to have also the natural gas in our facility available in our area. So we are operating with extremely low carbon emission facilities, DRI. We also have the first steel company that captures CO2 in our facility. We have also we started to test and develop the hydrogen project in our facility, and we have almost 84% of clean electricity sourced to decarbonize our scope 2. By the way, I want to share with you, this is our CDP score, so you can also get the full details of our decarbonization plan and targets in the decarbonization CDP report. By the way, this is the first CDP report that we submitted to CDP, and our current score is B-, which is above the Asian company, above the average Asian company and the global average of the steel industry. And also we are targeting to increase our score to A band by this year, so we will get the results soon in January. So this is the our, I would say, decarbonization evaluation performance. Last slide with me is that I would like to emphasize that our efforts are being recognized worldwide, even in different entities all over the world that recognize, for example, the World Economic Forum listed that Emirates Steel is one of the 5 pioneering decarbonization company in steel production. Thank you all, and any question, please.
Thank you very much, Muhammad, for the nice presentation and the effort seen by Emirates Steel, by EM Steel. We can see that really there's a big ambition, not in one aspect or two, but more, the all pillars you showed us. Well, I mean, we ran out of time, so I would say only just one short question, because also, yeah, the presentation seems very clear. The 84% solar plus nuclear energy, this is 84% of all energy needed in the plant?
If of all electricity needed in the plant. So in total, we are consuming almost 2.2 million megawatt hour per year. Last year, we have sourced 2 million megawatt watt from nuclear and solar IREC certificates.
Okay, very good. Good luck. Thank you, Mohammed. So let's switch to the last presentation of today. We have with us Naveen Ahlawat. I mean, Naveen, we are happy to have you today with us. Naveen, he leads the Power to X department in Jindal Steel, overseeing key initiatives such as green steel, green hydrogen, and CCSU across the group. Naveen holds a degree in the chemical engineering with honors from the Government Engineering College in Thrissur, Kerala, and an MBA from Indian Institute of Management, Calcutta. With over than 13 years of experience in various sectors, including manufacturing of specialty chemicals, coal gasification projects, co-products marketing, integrated steel plants, both brown and green fields, Naveen has built a distinguished career in the industry. Finally, Naveen was a part of the executive team that played a pivotal role in establishing the world's first coal gasification-based DRI in Angul, Odisha. Thank you very much once again, Naveen, for having you. Please start your presentation. Thank you.
Thank you so much, Mr. Karim, and thank you so much for your introductory remarks. I think this is introductory slide and very important to understand. The right hand side is slightly more important in terms of understanding the impact of basically the inaction. I think that is very important because there is a understanding, there is a basically sort of a inertia that is there among all of us, and we believe that yes, let someone else does it, and we can let them be the guinea pig, let them be the first mover, and then we'll come in, try to basically de-risk the overall value chain. And that is where actually the cost of inaction is. So if we just go with the current trajectory, I think we have to go for a rapid or accelerated deployment of carbon capturing decarbonization to reach the goal where we are. And as per the recently released report, we have already reached at 1.49 degrees centigrade, and I think the gigatons of the CO2 have to be reduced rapidly to really touch where we are. Even if we reach at 1.5 degrees centigrade, the GDP is going to shrink by 8%. So I think the cost of inaction is quite heavy. Forget about basically leaving a better legacy for our future generation or having an impact on the climate change. It will also have an impact on the GDP. So the country will definitely lag behind if we are not going to take action on this aspect. I think this is also important to understand that yes, if you see the overall GDP, I think contribution, the iron and steel sector, it contributes close to 0.7% of the global GDP, right? And you see the emissions, it is almost 10 times. So that's why it is absolutely imperative that we have to start working on the decarbonization of this sector. And how this thing is pan out, like if you see the different routes of steel iron steel making, 70% is being produced by BF and BF route. 6% is DRI electric arc furnace, and the remaining 22% is from the electric arc furnace with the help of recycled scrap. Now, if you see 72% of the BF route, the emission, total emission of 7% that we have, considering here, 95% it is being done, it is coming from this route, and 3 and 2% from the DRI electric arc furnace and electric arc furnace. So this 95% is where basically basically the lead domino where we have to sort of deploy or use different option to reduce the intensity. Now, if you see this, I think from the existing processes to the new process, it is very important to understand what are the quick wins, right? What are the easy, basically movers, or what we say that basically the shitters that we have, we can quickly sort of turn them around. And for that, the circularity, efficiency, renewable power, deployment of renewables, so they are the like sort of quick wins. We can immediately deploy and try to see the reduction. Now, the good thing about these, levers in the existing process is that the incremental capex, basically the capex to have these, levers implemented on the ground is close to 4 to 5%, right? But the impact that will have, these levers will have on the reduction in the carbon intensity, that is close to 10 to 15%. So that's why it becomes paramount to use these levers to start actually moving the steps, the incremental step that we all are talking about. From the new processes, low carbon hydrogen is definitely the what we they say the silver bullet. But then we can reach to the silver bullet even with the incremental step, as our friend Yoshim has explained earlier, that let's start with blue, have a low carbon intensity hydrogen, and then inch toward the green hydrogen, which actually right now it is not making sense economically on the delivered price basis, but then it will start making sense in next 4 or 5 years. CCUS can definitely play an important role. Basically, what we have found out that the impact of CCU on the cost of steel production will be close to 15 to 20 odd percent, but the impact it will bring in terms of the reduction in the carbon intensity, that will be close to 25 to 30%. So definitely it will also, it is from the medium to long term, this can also be one of the lever. And if we define the geography and zoom in the MENA region, this will become absolutely paramount because of the geographies, because of the basaltic and the peridotic rocks that is available, especially in the UAE and Oman. then and you have like a lot of permanent sinks available. I think this can be one of the interesting option to explore. And we at Jindal Shadid and Iron Steel and Vulcan Green Steel are absolutely bullish on this option, and we are going to start taking the trials within next 2 odd months, wherein the captured CO2 will start injecting in the peridotary rocks, and with our close collaboration with 44.01, and then we'll start seeing the results, and then we'll scale the overall size of the carbon capturing to close to 1 million tons, and then accordingly we'll start pushing that CO2 into the rocks. So this is one of the classic example of circularity, and one of the quick wins that we can easily have because of the geographical advantage that we have in this area. And then the fuel switch can also play an important role, wherein all the fossil fuels like the LFO, the light basically diesel or the low light diesel oil and the heavy furnace oil can be replaced with the ethanol or methanol, where we can start blending them and start using them. So this can also be a game changer as we move forward, as one of the quick wins for the new processes. Now, this is basically, you see here, just the idea is to show that, there are various steps, and all the steps can run in parallel. We don't have to be sort of, wait for one step to happen and then we go in series, right? So you can see the multiple starting from the upstream side, where we have to bring all our input material to the iron and steel making, and then the scope 3. So if we zoom in to the iron and steel making, we have deployment of renewable energy that we have just spoken. The biosyn gas can also be an interesting option if there are basically biomass available in the country. So this can also be basically an interesting option. Biocoal, biochar, can also be an interesting option along with biosyn gas, where we can sort of remove the anthracite coal, or basically the pet coke, and remove it and start using biocoal and biochar. CCUS, we have already spoken on that. On the upstream and the downstream logistics side, we can start exploring the blue slash green ammonia. Green ammonia is again the shipping side. If you talk about the maritime, talking to them, they are quite bullish on blue methanol at this point of time, and they are believing that yes, from the medium term up to 2030, by end of the decade, blue methanol is definitely an area where they are bullish on, and they have started ordering. Some of the companies like Maersk, they have ordered close to 25 odd ships which are going to run on the blue methanol. And then I think once we have the engines which can basically run on the dual mode, then we can sort of shift it to the green ammonia side, when the green ammonia the delivered cost of green ammonia will fall somewhere around $600-700 per ton, which at this point of time is like close to $1,000 to $1,100 per ton. Now, hydrogen, as I said, it is definitely a silver bullet. So if you talk about the hydrogen and the complexity that we need to address, and all these issues are being addressed side by side, it is not that they are challenges, they will remain the challenges. We are also parallelly solving the issues one by one. So starting with power generation, I think we need to sort of reach to a sweet spot of solar wind in case of a hybrid thing. We have to also sort of consider the wake losses that we are going to incur for the wind turbine. So we have to find out a sweet spot of how much solar, how much wind, how much long duration energy storage, because solar wind can only take us to 14-15 hours. The remaining 10 to 11 hours, we need to find out the solution for that, be it CO2 air battery storage, be it the molten salts, be it on the battery side, and exploring the more future ready technology like iron air and iron air batteries. Electrical infrastructure, I think this is also quite an important aspect, where we have to find out the energy storage technologies, and I've spoken about this. And second is also how we can valorize and utilize the clipped electricity, the curtailed electricity, because as a steel producer, I think if we have to synchronize the upstream side, the renewable side, plus the downstream side where we are going to run our steel operation, there can be a good sort of synchronization that can happen, wherein the excess clipped electricity, curtailed electricity, which will be generated during daytime, can be used for our steel operation. It can have an impact on the overall levelized cost of hydrogen, impact on the LCOH, and also on the LCOE. Electrolyzer, I think there are mature technology like alkaline, pressure alkaline PEM, but I think future ready technologies also we have to sort of look where, which focus on basically how we can reduce the number of electricity or the number of units per kg of hydrogen. So out of that, solid oxide electrolytic cell can definitely be a good answer where we can utilize the waste heat coming from slag or from the electric arc furnace fumes, use them, make steam, and that steam can be used as an input or as a throughput in this electrolyzer. They boast about electrolyzer efficiency of close to 88 odd percent, and the electricity consumption at a system level is close to 44 units per kg of hydrogen as compared to 54 units from the alkaline or the PEM. Selling of the byproduct can also be an upside when we have to calculate the levelized cost of hydrogen at the system level. So the oxygen that is coming out from the electrolyzer can be used in our DRI operation, electric arc furnace operations, and if you have got the blast furnaces as well, you can also use that as well. So it can, there is definitely a value that is associated with this oxygen. Then hydrogen storage, I think since we haven't basically found out a solution basically about the round the clock electricity electrons till that time. I think we need to basically find out that how in the during the daytime we can use excess electricity, oversize solar wind electrolyzer, and then generate excess hydrogen and store that hydrogen in the tanks. So storage above the surface tanks are basically they are they have a like it's a much more mature technology, and below the surface I think caverns can definitely offer a very interesting opportunity where the LCOS, levelized cost of storage, is absolutely very competitive. Along with these challenges, you see basically the basic, I think there is a solution across the value chain, and all these solutions, I think we have been working. So one of this is about, as I said, the sourcing or the security of low cost, low carbon hydrogen. So partnership is the only solution here. Otherwise, we need to sort of collaborate with other partners, because we have to play on our strength, and our strength is basically on the steel making side. So definitely the partnership can definitely play an important role here. The high grade pellets, I think speakers have spoken about it. It is absolutely paramount. We need iron ore grade pellets having more than 66% iron content, and the DRI electric arc furnace. As we move forward, right now the current split, if you see, it is only 6% DRI base electric arc furnace. By 2030 it will go at least 12%, and by 2035% by 2035 close to 15 to 16%, and by 2040 it will hit close to 22%. So selection of the right technology between energy iron and Midrex, it is absolutely important. Having the right set of EPC contractor, super critical. Having the right set of engineers, the pool of the talented subject matter experts, that is super critical. So we have to pay attention to this aspect as well, because in the wake of in the complexity, sometimes we sort of lose our focus on these small soft non-technical issues. So this is the motivation that we have. I think we all are aspiring for by 2030 close to 100 odd million tons of green steel demand coming from Europe. If we take the most pessimistic scenario, 50 odd million tons is going to be the demand, and we do all the capacity addition by all the announced integrated steel producer in Europe by Salzgitter, SSAB, and H2 Green Steel. All these guys, we personally we believe that they won't be able to go beyond 10 to 12 million tons, right? So there is an upside of close to 35 to 40 odd million ton steel, and that will come from the from Asia or from the Middle East. So this is actually the opportunity that we all are aspiring, and it is a good opportunity. So along with reduction in the carbon intensity, this green steel also present a very good business case. I think this is another motivation about the final consumer like you and me buying a 30,000, 40,000 euro car, and where the incremental capex or the money that will go from our pocket if we have to source our appliances like washing machine or car from green steel or low carbon emission steel, it is not more than 1%. So I think it is also another motivation. There are a lot of studies done to gauge the interest from the final consumers, and one of the interesting case study was done by Boston Consulting Group. During COVID time, they asked the consumer that how much they are willing to pay premium, or are you willing to pay the premium? Only 10% of the final consumer, they said that we are willing to pay the premium. The same study was done last year, and a whopping 70% of the consumer, they said that yes, in order to really create an impact or make an impact on the environment, and to leave a better legacy for our future generation, we are willing to pay the premium. So this is the change in the perception over the years, because all these changes, the climate changes are happening across the world. They are not saying that okay, there there's any boundary. Across the globe it is happening, and that's why it is actually having an impact, and it is impacting the overall consumers to really change their stance on this. This is actually our 5 million ton green steel plant that we are busy putting up in Dukum. 2.5 million ton, two batteries. The first battery will be commissioned by FY 26-27. Second battery within an interval of 27-28 that will be commissioned. So the project is absolutely, we are in a very high advanced stage of construction. We have placed the order for technology on energy iron. So we are quite excited about this project. And this is the goal. The goal is to reduce the carbon intensity, the global intensity at 1.8 to 600, so close to 75 to 80 odd percentage through these levers. Use of hydrogen, close to 400 odd kgs impact. 600 is through the use of electricity, renewable electricity, use of biocoal, use of scrap. All these levers are adding value, and you can see the impact that they have, to reduce the carbon intensity from 1.8 to 500. I want to just play a video. I know I'm running behind the time, but I think it will also motivate us to really, push this decarbonization.
Our climate is changing. We have understood that we need to act right now. And we are already changing the way we live our lives. Around the globe, industries explore new routes and strive for transformation. A transformation that can only be done with steel. Mobility, renewable energies, our private lives. Steel is omnipresent. At Vulcan Green Steel, we are part of the Jindal Steel Group, and we have a vision. By 2030, to deliver green steel, with 85% less CO2 emissions than blast furnaces. Produced with renewable energy and with green hydrogen. A giant leap towards a reduced carbon footprint. We want to help our customers to make our future greener, better for all. With Oman, we have found a strong partner who shares our vision, who supports our ambitious plans with a sustainable mindset like our own. Together with Oman, we are fostering innovation, industrialization, and sustainability, fully in line with the Oman Vision 2040. And Oman has more to offer. A world-leading solar profile with 3,500 hours of sunshine every year, and a superb wind potential on a par with that of the world's best location for wind power. In short, ideal renewable energy conditions for the green steel production of tomorrow. Therefore, the inception of Vulcan Green Steel is a massive investment in the future and the region. In Duqm, we're currently building an integrated steel complex, the first of its kind in the GCC, and with direct access to its own jetty for a more sustainable supply chain. The Vulcan Green Steel Plant, producing 5 million tons of low-emission steel every year, powered with 100% renewable energy. With our vertically integrated steel mills, we will produce green steel in Duqm for industries like automotive, wind power, and home appliances. The Vulcan Green Steel project in Duqm is the world's best bet to make green steel before the end of the decade. We strongly believe in this visionary project and in our partnership with Oman. That's why we commit to our green pledge today and for the future.
So last slide, thank you. I think it's not going to be a walk in the park, but I think if we are prepared and we have already started the climb, and this is the only way how you can convert this hard to abate sector to the possible to abate sector. Thank you so much.
Thank you, Naveen. Very nice presentation. We liked it much. It gave us insight what's going on also in Oman, and the video was very nice. Yeah, we hope all the best for Oman. There's a lot of potential there in terms of green energy. So, and this is a place that yeah, investors should always think of. Thank you once again, Naveen. Appreciate it.
So much.
I mean, maybe you just can say something about when is the startup is planned?
So as I said, the first battery of 2.5 million ton will be up and running by FY 26-27. We are going to start the battery with natural gas, and then we'll do the transitions. Our target is to do the complete transition by FY 31 for the first battery. The second battery will come up and running within an interval of 12 to 15 months. So FY 27-28 is what we are aiming for right now. So we are in an advanced stage of construction, and I am actually want to welcome if anyone want to come and visit the plant. I think it will really motivate the audience and anyone who want to come. So the construction is on full swing. We have started. We have right now, as we speak, we have like closed the ordering procurement cycle to. We have ordered all the packages by close to 70 to 80% odd. So only 10 to 15% procurement is remaining at this point of time. Construction is close to 15 to 20% odd completed, and we are on target as we speak.
Best of luck. Best of luck.
Thank you so much. Thank you.
Well, at this stage, we have again to thank everybody from the audience here, from the speakers as well, who give 2 hours from their time to give their experience with us, with the audience. So we thank again all speakers, all audience. Our thanks also is extended to our event sponsor again, CV Engineering, for sponsoring this event. We would like again to get a chance of this opportunity and tell you, please get alert for our new event of new Steel Forum event in the first half of next year. It will be in Cairo. Exact day will be announced soon. We would be happy to have, it will be 2.5 days, same like in 2023, 2 days for technical sessions and networking, and have a day for steel plant visit. So please, we would like to have you all with us in this nice event. Thank you once again, and have a nice evening. Thank you.